All right, our last video for chapter 14, we're just going to talk about some probability trees, which is our last one to do. And so hopefully this goes through pretty quick compared to the other videos. Anyway, Leah is flying from Boston to Denver with a connection in Chicago. The probability her first flight leaves on time is 15%. The probability, if the flight is on time, the probability that her luggage will make it to the connecting flight to Chicago is 95%. However, if her first flight is delayed, the probability of making the luggage is only 65%. Are the first flight leaving on time and the luggage making the connection independent events? So again, independent would mean my probability does not change. Whether my first flight was delayed or not, the likelihood of getting my luggage should not change if they are independent. And it just told me that they did change. So therefore, not independent. Probability of luggage probability decrease. Luggage probability decreases when first flight is delayed. All right, and finally, what's the probability that the luggage arrives in Denver with her? So here we go. This is what here's Leah. She is going to take a trip. She is flying. Her first event is that she flies. She flies out of Boston, and that flight is either on time or it is delayed. Now, when she leaves Boston, it says the probability her first flight leaves on time is 15%. So there's only a 15% chance that it leaves on time, which therefore means there's an 85% chance that it's going to be delayed. So she's going to make that connecting flight. She arrives in Denver. This one, she arrives with her luggage, and this one is without her luggage. So she has a 95% chance of making, if she leaves on time, there's a 95% chance her luggage arrives with her. So that means there's still a 5% it doesn't. If her first flight is delayed, then, again, we have the luggage and we have without luggage. And but if her first flight is delayed, there's only a 65% chance that her luggage carries on or gets on. So that means that the 35% that's not. So what happens in a probability tree? We just take the branches, the limbs times the branches. So I know that the probability of leaving on time and getting air luggage is going to be the product of 15 and 95. So I just have to multiply those together, and that's going to give me 1425. Okay, now the thing is, I don't necessarily want to have to do the whole tree because I don't have to do the whole tree in this case. I want to know what is the probability that her luggage arrives with her. Luggage arrives with her. So in this particular outcome, I get luggage. All right, so that means I'm going to want 1425. But in the next one, all right, this is without luggage, so I don't even need to calculate this one. Down here, I get a luggage here in that first option, so that means I'm going to have 85 times 65. And when I take 85 times 65, we get 5525. And that would be the other incidence in which I get luggage. All right, so she got her luggage in that one. So what we're going to do is, in order to find out what is the probability of landing with luggage, is going to be those two things added together. So that means that is a 695. So remember Leah in exercise, I was that way wrong. Suppose you picked her up at the Denver airport and her luggage is not there. What is the probability that her first flight was delayed? So again, the more we can understand about conditionals, the easier this gets, all right? You picked her up at the airport and her luggage is not there. So there is a condition, all right? The condition is there is no luggage. What is the likelihood the probability was delayed? So again, this is the hard part, and this is where I'd strongly encourage you to use notation because that helps out a lot. So I need these numbers. I need delayed and no luggage. And I'm going to divide that by then no luggage. Now the problem is I don't think I have any of these calculated, okay? Meaning I want delayed and no luggage. So here is delayed and without luggage. So I actually need this guy right here, which I did not do. So I am going to have to take 85 times 35, and that is going to generate a 2975. Okay, so I needed that number of 2975. Now, I also need no luggage. Now, the problem is my other no luggage is going to be right here, so I would also need 15 times 0.5. Or, since I know what the likelihood of luggage was 695, the probability of no luggage is going to be 1 minus 0.695, so that's going to give me a 0.305. And so that means there is a very high chance that our first flight was delayed. All right, this is the last question, so hopefully, again, this video was short. A company's records indicate that on any given day, 1% of the day shift employees and 2% of the night will miss work. 60% of the employees work the day shift, okay? So our absenteeism independent of shift worked, and again, that's going to be a no response. My absenteeism rate gets higher on the night shift. What percent of employees are absent on any given day? So here is our employee. Okay, lunchbox, briefcase, whatever, they're going to work. Anyway, the first event that happens to this employee is they either work the day shift or they work the night shift. It says that 60% of employees work the day shift, so that means the 60 goes here and a 40 goes here. And then at the beginning of the problem, it said on any given day, 1% of the day shift employees are absent. Okay, so my next event is either they are absent. We'll go with underneath. Okay, we are working or we are absent. And if we come down here, those are the same two things. We are either working or we are absent. Now it says that on the day shift, 1% are absent, and on the night shift, 2% are absent. And it says on any given day, what percent are absent on any given day. So I'm actually not even going to worry about any of those working numbers, and I'll probably regret it because I'll want it on the next problem. But, so we're going to know, I have to know what 0.6 times 0.01 is, and hopefully we can do that. Anyway, that's going to be 0.006. And then we're going to come down here, the other one, we're going to take 0.4 times 0.02, so that is going to be a 0.008, and we're going to add those together, so the probability of being absent is going to be 0.014. All right. At the company described at exercise 47, what percent of the absent employees are on the night shift? So we have an employee. We know the employee is absent. What is the likelihood they work the night shift? So again, probability, writing, that's why maybe I should have forced us to write statements. I can't force you guys to do anything. But anyway, encouraged you to write out this because if we can, again, it is both divided by the condition. Okay? So both, night shift and absent. So here's night shift, here's absent. You can't see me pointing. Here's night shift, here's absent. That probability is a 0.008. Absent employees, well, we did that probability up there. It's 0.14. So when we divide those out, that is going to be a 5.714. All right, that was much, much quicker